Hello friends, welcome to my YouTube channel AI Hack by AK. So friends, in this particular video tutorial, we are going to discuss the gradient descent. Gradient descent is basically one of the most fundamental and used by all the machine learning algorithm for the cost optimization and parameter tuning. So when I say cost optimization, what is the cost here? So So basically, if you say in machine learning language, the cost is defined as the difference between your your actual minus the predicted value minus your predicted value. So this equals to your cost. And when I say how do you optimize cost? When I say optimizing cost, it basically means that finding finding parameters or weights which when applied to your input data produces results which are most closely resembles your actuals. Closely resembles your. So means the difference between your actual and predicted should be as minimum as possible. So with whole process is this called cost optimization. And is gradient descent lets you do it very efficiently. So we'll just understand what is gradient descent with an example.
So now let us try to understand this gradient descent with an example. So for example, I have a data set here, okay, which is about their house prices and the price house square feet of house and their prices. So let us say these are basically the square feet of house and these are the price. So we have 1000 square feet which is a price of 400,000 K. Then we have 2000 square feet, which has a 8000 K. Then we have a 3000. Then if we have a 12,000 K, 4000. Then for 4000 we have 16,000 K. Okay, and then 5000 we have, for example, we say we have around again around 19,000 K, you can say, right? Now, what happens is that uh, this gradient descent has a following steps. So first is that it will initialize with with random weights. Second, checks the error, checks the error which is basically you can say y minus y hat, which is your actual versus predicted value. Adjust the weight, then again it goes back to 2 and 3. So after adjusting the weight, it will again go to here. Sorry, after it will again go to here, check the error, and then again it comes here. So this keeps happening until the cost or error is minimized. So let's start with this. So for example, we have given a weight here. We initialize with a weight which is w is equal to 2. So since this problem is a kind of linear regression problem, so we assume that your y, which is your price, is dependent on w into some weight x. So w into x, x is your input, which is your square feet of out. So we say that, see, we say that when we multiply with our some weights w, which is our parameter or coefficient, and some weight w and the input x, we can get the actual value of y. Now, for example, once we say that it is initialized with w is equal to 2, so w into x, so for the first observation, the w into 2, it is coming, w into 2 for first observation, it is coming as 2000. Then, so this will be your y hat, and this will be your this will be your error. So what is the error here? So actual minus predicted, the error will be 2000. So, so as soon as the gradient descent algorithm sees that the error is a 2000 error, there is an error, so it tries to minimize error. So the complete objective of the descent is to minimize the error by adjusting weights. So as soon as see that it is a 2000, it will try to increase or decrease the error. So that I will tell you how it happens. So this is 2000. So for example, it has increased the weight. So now the will be new weight will be 3. So once it goes for 3, so it will apply it for the second observation. So when you apply for the second observation, so this 3 into 2 is equal to 6000. So now again the error is a 2000. Again the error is not reduced, it remains the same. Again it say that okay, the new weight will be 4000. Now as soon as it says it is a 4000, you can say the error is reduced, it is 0, right? Now the same 4, since the error has been used, it is goes for the fourth observation. So this is again 16,000. So for 16,000, it is again error 0. There is again one observation remaining, that is 5,000. So when the error has been applied to 4,000, to the last observation 5,000, so it is coming 20,000 predicted, but there is an error of 1,000. So as soon as this algorithm sees that now the error is coming, it will again, as I said, you adjust of it. It will again try to reduce this 4 to some lesser value because this is the error we are coming, which is a, so it says that since the error has come, so there should be some lesser way, so it will might go to around 3.9 or 3.8 or something like that. And in the same way same way the the gradient descent work for each and every observation. So this particular kind of gradient descent where the weights are adjusted after each and every observation, it is called the stochastic 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 gradient descent, cresting gradient descent, or in short, you say it as SGD, right? So basically, what happens that if you say that your your cost is this, okay, your cost is increasing here, and this is your parameter weight, which is W, and your equation, um, your weights, um, value of your weights are like this. Then as soon as it comes here, as soon as the something is here, okay, and then cost is high, it tries to reduce the weight. So weight will be reduced or weight will be increased so that it can come here. So objective is to come here. Okay, so this is the your objective. This is your objective, and this area is the value of this area for W is the op it's the optimum weight where cost is minimum, where cost is minimum. Okay, so if you are initializing from here, then it will increase the weights because it can see that cost is basically decreasing. If you are initializing here then you can see that it will decrease the weights so that it could come here. So objective here is to come here. From here also it should come here. So for example, if maybe the weight 3 is here and weight 20 is here, okay, if you are giving 20 weights, then if you're initializing with 20, then is slowly it will decrease. If you are giving the 3, slowly increase it will increase the weights. Okay, so basically so how the new so what is the equation, which is very important one, is that so this will be, for example, your weight, okay, and this is your old weight, okay, and if it is here, then it is minus some steps and the old weight, right? So this is the factor where the weight should be reduced. I will explain it in some other video. So this is basically how the gradient descent algorithm works, and how the descent algorithm works. Okay, I think I have just given you an intuitive understanding of gradient descent and algorithm and how this algorithm works. Uh, and this is basically a fundamental algorithm when you go to the deep learning neural networks, and many in many algorithms. So the main objective of the gradient descent is there so that we can optimize cost and find the parameters which, for example, W in this case, if you go to this neural network, there will be some other parameter. There are a lot of parameters in neural network, like number of epochs, number of batches, that all parameters which will ultimately reduce your cost. So the ultimate objective of the gradient descent algorithm is to find the value of parameter or parameters which, when we apply to our input data set, give us the reduced cost, right? So thank you. I think you have enjoyed my video and you have enjoyed this explanation. Uh, and I hope please do subscribe my channel and give us comments if you want to know about something, and if you find my way of way of demonst demonstration way of demonstrating thing um, good, then please comment and even write in comments what you want to see next. Definitely. And I will be, after this video, I will be, giving more videos on the deep learning and all that. So I think please do subscribe and hit like if you have liked this video. Thank you.